Hey guys, let's do example 29 here. This is another potential energy example, and we're going to go ahead and draw out the picture. Alright, so we're going to have let's think of a metal rod here. It's going to be pinned here at O, and it's kind of in an L shape. And then it's got a ball up here on top. Alright, so it looks something like that. Now we're going to have a spring that's attached between this point and then top of the ball. So it's like that. All right, and that weight there for the ball is 9 pounds. And our spring, the spring constant, is 1.2 pounds per inch. And then this distance from here up to here is 10 inches. And then this length, this horizontal length, is 24 inches. Okay. And then finally this length right here, the vertical length between the two pins, will be 26 inches. Alright, so that's what we've got for our picture. Now what we're going to do is we're going to have this ball, it's going to drop down 10 inches. Alright, so think of, it's being held in place here, we let it go, and then it drops down 10 inches. Okay, so now what we want to do is we want to find the speed of the ball once it's dropped down that vertical distance of 10 inches. Okay, and it's going to be released from rest at this position, and we're also given the unstretched length of the spring. So the unstretched length is 25 inches. All right, so we're initially at rest, and then the ball is going to drop down. Okay, now let's draw what it looks like at the end. All right, so there's our pins again, and now let's draw it like this. It's going to look something like that. So now here's our ball, and then here is the spring. Okay, so it's basically going to have the ball even with this pin right here. All right, and we want to find the speed of the ball at that point. Okay, so that's what we're looking for. Now, first things first, you got to figure out how to solve this problem. If you see a problem that looks like this, you should automatically think to use the potential energy equation. All right, the U equals delta T plus delta VG plus delta VE. All right, and that's because we're going between two positions, right? We have a start point and an end point. We've got springs involved. So anytime you see anything like this, just automatically go to that equation. All right, and remember what the equation is. Let's write it down. So there it is. All right. Now the T part of this equation, remember that deals with velocities. Okay, so we got that. This one deals with height. This one deals with the stretch or compression of a spring. All right, so we're going to start with this one first. So let's deal with that one. And I need to find the initial length of the spring. And then we'll also find the final length. All right, so initially we need this length of the spring. Well, if we look, you can use a right triangle like we did in that last example. All right, we can do that. So this length right here will be this 26 inches minus the 10 inches. That's 24 inches. Now, we don't want inches. We need to convert over to feet. So 24 inches is obviously 2 feet. 10 inches is 0.833 feet. And then 26 inches is 2.167 feet. Okay. And let's go ahead and convert this to. So your spring constant will be 14.4 pounds per foot. Okay, so now that we have that, let's use this right triangle to find the length of the spring. So we'll do the square root of 2 squared from right here. So that's this base plus 2.167 minus 0.833. And then we square that. And that gives you 2.404 feet. Okay, so that's our initial length of the spring. Now let's find the final length. So our final length of the spring is right here. So if I can find this distance and that distance, I can find that length, right? Well, this length right here is easy. That's given in the problem. That's 2.167. Now, this length, that one, let's look over here. I'm given this length here and this, right? So this is a rigid structure, right? So it's going to have that same shape regardless of where it's located. So if I have that line, is this line not the same thing as this line? It is the same, right? So let's go ahead and find this distance, and then that'll give me this base of this triangle. All right, so that, if you do that, you'll have, the square root of 2 squared plus 0.833 squared. You end up getting 2.167 inches. All right. And that obviously is 26. Wait a minute. This should be feet. 2.167 feet is 26 inches. All right. Now that we know that, our new length of the spring, since this is 2.167 and that's 2.167, we're going to have the square root of 2.167 squared plus 2.167 squared. That's 3.065 feet. Now that I've got this taken care of, we can go ahead and start filling out this equation. All right, so let's go ahead and do delta VE. So that's going to be the 1/2 times K. K is 14.4. And then we're going to have the final X. All right, so here we are. So the final length of the spring is this 3.065. Now, should I just leave that there and square it? No, we should not do that. This is the final length of the spring. We need stretch or compression, right? So I need to figure out how far that spring is being stretched. So I need to take this amount and subtract the unstretched length. All right, that was 25 inches, so this is 2.083 feet. All right, so subtract those and then we square it. And then we're going to do the same thing for the initial length. So here was the 2.404, and then now subtract the 2.083. So that gives us the initial stretch in the spring, which is what we want. Square that and then close that bracket. And this gives you 6.202 foot-pounds. All right, so now we've got that. Now let's go to the VG term. Now for this one, you got to find your reference line and always measure from that line. So you can pick wherever you want, but you got to measure both the initial and final locations from that same line. So I'm going to pick this right here as my reference line. Okay. And this equation, remember, this is mg times delta H. So mg, well, that's weight. I was given weight, right? It's 9 pounds. So I got 9 pounds right here, and then I'm going to look at my final position. If my final position is right here, then what should I have here? 0, right? Because it lies on that reference line. Because remember, the ball is dropping down so that it lies right across from that pin. So that's where I had my reference line. So that'll be 0, and then initially we're up here. So if I'm up here, then my H1 has to be 0.833. Okay. Now you're going to get a negative number. You get negative 7.9 or 7.497. Right? And again, that's foot-pounds. And then finally, we go to kinetic energy. So that's going to be the 1/2 times the mass. So for mass, we need to take the weight, which was 9, divide it by gravity. And then we'll have the final speed, which will be the speed right here at this point, minus the initial speed squared. So our initial speed was 0, right? Because it said it was at rest. So we have that. And this gives you 0.1398 v squared. Now just put all of these terms in your equation. Now what is u before we do that? What's u going to be? We don't have an external force, right? So that's going to be 0. Most of the times in these problems you're going to see in all the textbooks, this term will be 0. So we got 0.1398 v squared minus 7.497 plus 6.202. Now all you got to do is solve for v. You get 3.04 feet per second. All right. So once you get the hang of this equation, this stuff is really pretty simple. The thing that usually messes people up on here is when they're dealing with springs, they don't find the stretch or compression. They just put the length of the spring. Okay, no length. You don't want that. Stretch or compression. And the other thing is people don't use a reference line when they find these heights. They just randomly start picking values for the height. All right, you got to measure from the same point for each of those values. All right, otherwise it's not going to make any sense. Okay, so those are the two main things people mess up on. All right, so hopefully you will know not to do that. All right, so let's stop this one here, and I think we have one more example after this. We'll do that one in the next video. See y'all then, guys. Thanks.